Hello and welcome back to another episode of Dad's Diag. I'm here again with the garage door opener. I've been having some strange problems where when it's cool in the morning, it won't work with any of the remotes. The only thing that does bring it up is the button. And the only thing I can think of is, well, it works fine when I get home at night and it's warmed up and it opens just fine all the way from the street. But it only gives me a problem when it's cool in the morning. So I'm kind of figuring this problem may be temperature related. So I'm going to tackle the only problem I can think of that may be a temperature related problem, which is a bad solder connection on the control board. So I have already gone up the ladder and I have removed the control board from the unit. Everything else appears to be okay. Just a bunch of limit switches and things like that up here. So let's do a resolder job on the control board, and there it is. A lot of connections. I'm going to hit as many of them as I can, and especially the big ones. Anything that may be related to expansion, contraction with solder connections. That's something that happens to a lot of instrument clusters in cars. I fixed a Buick like that just by resoldering them. So I'm going to give this a shot and see if I can bring this thing back to life when it's cool. And I won't even be able to tell until tomorrow morning when I try to leave for work. So let's get to it. All right, let's get started resoldering. I could not see with a magnifying glass if any of these connections are broken, but I'm hoping I can resolder it and reconnect whatever is going wrong. I gotta crank up the temp a little bit. That's 700 degrees. So yeah, my hands are a little shaky. That's what happens when you get old. Put a little bridge of solder between the tip and the thing you're soldering, and then just add. Most of these boards are wave soldered, which means they put the whole board through a pool of solder and flux. Many of the components are glued down. And that's what leads to a lot of the solder cracks. This is the connector I'm soldering now, the connector with the rest of the control parts. Motors, switches, power, all goes through these connectors. Watch for solder bridges. It will be the death of you. Moving on into the power supply section. I may take out a capacitor or two and check it to see if they're any good. I know the sensors have a problem with heat cycling. They have capacitors in them that just go bad. And that's led to a lot of door opening problems. It's the main transformer. Beautiful late September autumn day. Temp outside is about 70. It's perfect for doing this kind of work. The problem seems to exhibit itself when the temp goes below 65. Once it warms up, it works perfectly, which makes it difficult to troubleshoot. I'm not going to resolder any of these surface mount components. That can be dangerous, as when you heat them up, the whole part heats up and then falls off the board. I don't have suitable replacements. That's the antenna. Going after the larger solder connections first. It's connections like this, you see, the part just flops around in there. And there's some large resistors. see. Let's get some of the diodes up here in the power supply area. I'm not sure which particular area of this board could be causing me the problems. Because either it completely works or it completely does not, as far as receiving RF is concerned. This is the RF section here. See the antennas here and the coils for receiving it. Try to get all the components that come through from the other side. There's another look at the board. Receiver area here. Control. Crystal. Clean off a tip. It's a regulator chip. Should check these capacitors. This, the electrolytics tend to have a problem with age, and this board is about 27 years old. It's been around the block. Two more. Why don't we do that? I'll bring in my component tester. It'll be able to test if it's good, and it will tell me the actual value of the part. If this part is not the correct value, then it will have to be replaced. That could also be the problem. Electrolytic capacitors are very sensitive to temperature. The value would change as the temperature changes. So why don't I pull, let's see, what is this? 4.7 microfarads at 50 volts. That's what these two are. And this one is very tiny. And very hard to read. This is 47 at 10 volts. Check these. These are in the RF receiver section here. This is power supply. If the power supply capacitor goes bad, that's 35 volts, 330 microfarads for the big black one here. So let me get out my component tester and we'll pull those and check their value. See if they've changed or gone dry. They have electrolytic fluid in them that gives them their value. If they go dry, they open up, the value changes, and they no longer function. Alright, let's start desoldering. I'm going to use something called solder wick. It's just a wire mesh that soaks up solder. So there we go. And the solder on the component. Sucks right up onto the wick. Let's see if she's loose. Yep, came right out. Doesn't look blown out. Let's see if I can get this into The test. .28 picofarads. That's not right. Let's try that again. Picofarads. Could it be that this component is just open? That would certainly give us a problem when it's cold. Test it a few times and make sure this device is working. .28 picofarads. Let's try another slot. Feels like it's in there. Now it's saying you can't even see the part. .32 picofarads. Yeah, it's looks like it's trying to. Let me try it with a different meter. For me to have found the problem that quickly. 35 volts, 330 microfarads. Hope I have one floating around in all my junk. Let's get a multimeter that I can actually trust a bit more. Alright, I'm back with the Klein Tools meter on the capacitance scale. There. And I've already lost a component. Where'd he go? There he is. This on plus. .227 microfarads. I don't think that other machine is working right. .150 microfarads. It's all over the place. I don't like this capacitor. I think I'm going to replace it. I don't know if you can see the numbers, but it says it's supposed to be 330 microfarads. I'm reading about half that. So let's go find another 330. Or thereabouts. It's on the power supply output. Anything over 330 should do the job. And it goes right there. Well, let's see what I can find. Looks like I found something here on an old brick power supply. 470 microfarads at 50 volts. Well within spec. Let's get one out. Should only have to heat it up. 1, 2. And there's our replacement. It's a little taller, but I don't have a problem with space. I have a junk drawer full of electronic components that I save just for this type of an occasion. Let's measure this one while we're at it. Put that on the plus, and .445 microfarads. Darn close. I'll take it. So let's put this in. Oh, it even has spaces for different size. And the holes match up. Look at that. Perfect fit. Let's bend the leads over a little bit so it doesn't fall out while I'm soldering it. There we go. Where was it? Right here. Add a little solder. And there we go. New part installed. As I said, that can happen. Electrolytic capacitors are usually the first things to go on any electronic board. This is 4.7 at 50 volts. Let's see if it is 4.7 at 50 volts. If it is, I'll put it right back. 4.4. Close enough. Now let's get the, where's the solder wick? Let's get the holes opened up again. Be these two. Do I know how much it would cost to replace this board? Nope. I can guarantee it's too much. Enough that most people would say, get a whole new one. But I'm not like that. I fix. The yellow line there is negative. I don't know if you can see that. And I'm sure I'll probably have a little trouble focusing. This camera only has a focus length of about 18 inches. There we go. And let's put him back in. Nice job. Let's try this other one here. Pull him out. Same value. Plus lead on and hold that there. What do we get? 4.4. Close enough. It's supposed to be 4.7. I'll take that as being good. They do have tolerances of a few percent here and there. 10, 20. And I'm just solder wicking the holes to open them up again so I can put the component back through the holes. And look at the plus. Make sure you've got your polarity correct. Bad things happen when you reverse polarity on these guys. They tend to short out or catch fire depending on how much power is applied. And little solder. And so I use very little solder. Doesn't take much. Here we go, he's back in. Alright, I've resoldered a lot of connections on the board, made them stronger at the very least. Found a bad component that was replaced. And that is probably filtering. This is a 7805. So there's your 5-volt regulator chip for this. This is a special one made just for the garage door opener. Power transformer. These are relays. Control chip. This I'm sure has something to do with the receiver. And if there's enough ripple, see when you take a capacitor out and put the wrong one in, lower value, or it opens up, you get what they call ripple. It's supposed to be a nice smooth voltage output, and if you take the capacitor out, you get the 60 cycle AC riding on that, and that causes havoc with the rest of the system. It just won't work right. The voltage won't be correct, and you'll induce 60 cycle interference throughout the whole circuit, and it'll just simply cease to function. So why don't I try putting this back in, and I'll have to come back at a later date and tell you if it all worked, because now all I can do is wait for cool weather. But I'm pretty sure this is happy. This is an old unit. This is about 27 years old. First one I put in the garage. All right. Put away our tools. Decided to take you along for the reinstallation. Board fits in here like this. This plug gets attached. I have it unplugged, by the way. I will not be lighting up like a Christmas tree. Route the antenna through. Hook up the light. There we go. These wires, route them on the outside. It doesn't look like it's fitting quite right. Seems to be the problem. Blue wire. It should be on the outside. There we go. There we go. He's in place. Get my little stubby screwdriver. Whoa. Of course it had to hit the ground. start them by hand. That way I won't lose them. And another one. Yep, one more. In here. I get you closer, but the camera can't focus that close. You may have seen that when we were soldering. For that, I apologize. I'm using a DJI Action 4 camera, and the kids got me for Father's Day. It was very nice of them. Very good camera. Might have to get a different screwdriver. Back together, all plugged in and ready to go. Let's get the cover back on. And that light bulb. Give me some oxygen. Fine threaded screws or metal. Let's get those in. Caught up. That down. How confident am I that this did it? About 80%. Leave myself some room for doubt. I zip tied these so I know which wires went where. And now I'll twist these together. Twist these two together. And let's find our stubby screwdriver. One. Single wire there. All right. That should be all we need to do. Let's give it a test. Still works. Let me reattach the garage door to the latch. Okay. Should be able to open the door now. Now let's see what happens when it gets cold. And that's going to be another day, maybe tomorrow morning. Not quite sure what the temperature will be. It might be in the low 60s, upper 50s. That'd be a good test. If you're thinking it has something to do with my lights, they've been unplugged since I did that video. So they're not interfering. So now we find out. There may be some bonus video at the end of this. Look forward to it. All right, I've got a little bonus video for you. It's been about a week and I have had 0 problems with the garage door opener in any temperature from any distance away with the remotes. That was the fix. That faulty 5-cent capacitor was the cause of many of my problems. Did it fix the problem with the lights? I don't know. Let's give that a test. They're all lit. Now let's get a remote. And the garage doors work. And let's try walking a distance. Still interferes. Get closer. So the lights still cause a problem. All the capacitor did was free it up when I'm inside the garage. Other than that, the lights are still a problem. So I keep them unplugged when not in use. I will be using them come Halloween. Now I can go full test. Let's go back out. All right, that proves it. The lights do cause a problem, even when everything's functioning perfectly. Take what you want from that, but that's as good as that garage door is going to get, and I'm happy with it. It should last another 10 years, unless mechanically it goes down the tube. So thanks for watching, and join me again for another edition of Dad's Diag. See you later.